Start with the hard stuff. I mean,
like the hardest shit you find.
Oh shit! Well, I got to grab some.
I feel like that's a good idea because we're not brain dead yet. So start with the hard shit.
Like question 4 and 3. We start 4 3 from the actual review, not from the other review. 4 3. Then move on to the CFU.
Yeah.
That's my suggestion.
That sounds like a plan.
Or we just sleep.
Pretty much print this out and bring it to like test tomorrow.
Do you actually want to go get coffee?
Let's go get coffee.
You want to get coffee? You can eat lunch like that.
You can get a monster.
I have a monster. Well, I'm not there yet.
Bro,
I got like 4 of them.
you're horrible.
I'm not gonna offer you.
Who are you?
Sorry. All matter.
Interesting.
I don't want that monster slow anyway. Enjoy your gallon of your 30.
Ow. What's your name, bro?
Josh,
Abraham.
what's your name?
Abraham.
Abraham?
Hey, put up see if you know on that one. On any of the screens that I can see.
How do I do this?
Out of functions.
So I was talking. Mo and Chandler agreed. We start with question 4 and 3 from our actual review. Then we go into 4 3 from the other review. Then we go to the CFU. Let's do the hard stuff. And else before we die. What do you think?
I don't know. It's whatever. It's whatever you want.
Alright.
We can do. Oh Christ! We can do the review.
Yeah.
Okay. So 3, 4.
Let's do 4 3.
4.
What?
4 3.
Yeah.
Or
Review.
Yeah. No more culture.
Posture?
yeah.
All right.
So you want me to go that?
Yeah. Bring that up and then zoom it in, so I can fucking see it. Blind eyes.
Where's the nearest bathroom? Up here.
Just stick to the
I don't
wall.
know, somewhere.
I think it'll find it.
It's,
Go around the
I'm pretty
perimeter.
sure it's around that way, like right across. So if you walk towards the RGC, it's behind that. Okay. All right. So. This is the wrong way.
What the fuck is it? How do you fucking zoom in?
Okay. So we've got some shit.
So, bro.
So, man. Okay.
For the review?
Yep.
Alright.
All right. Jesus Christ. Can we do this? Does that look better? Or does this just look terrible either way? Well, let's see. I think this looks terrible either way. Oh well. So we can go with the explanations then. So. Squared. Okay. So for this problem, right? We got our stuff, and we've got P1. Why? God damn, you really cannot see that, can you? I wish I had like a little iPad, like switch the view over, but whatever.
Maybe you can borrow an HDMI cable from them.
Hmm?
Maybe you can borrow an HDMI cable from them if you want.
Yeah, but I can't like write it down or anything. Oh, I know what I can do. Is this even here? Where did my work go? Whatever. Alright. So, to find.
You have to get the key through them, or we just pass it off to them.
Alright, finding the complete shear flows in this 2-cell section, right? So we'll call this left,
Yeah.
call this right,
We'll give it to you.
and say, okay,
All right.
so whenever we are finding shear flows in a section, we have to cut it, right? Because we have booms. Got booms, therefore we got to cut it, got to make sure that our flows are open. So we say that, right? Cut the left, cut the right, because that makes this QSL and this QSR. Right, so we have a shear flow on the left going counterclockwise, we have a shear flow on the right going counterclockwise. And in between it, between booms 1 and 2, we have the shear flow 1 and 2. Right? Q1, 2. So one of the necessary things to understand when we're doing this shear flow problem is that, which is different from the other ones, is that this left shear flow and this right shear flow only exist on this part of the perimeter, and that's it. They don't go in to the QB or the Q1, 2. We'll get there then. So we cut the sections, right? And we're gonna have to say, all right, well, this is 0, this is 0. We're gonna have to say some things, right? So we know that we can talk about Q1, 2, right? We can say that Q1, 2 is equal to QB1, 2
I'm going to the
minus QSL plus QSR.
I'm gonna start.
Right. So this is big important equation number 1. Big important equation number 1. Right. And we're going to use this because when we end up writing our later equations, we're going to have a Q1, 2 related to QSL and a QSR. And if we don't do this, then we don't have enough equations and we get fucked. And nobody wants to get fucked by this question, right? So we say, okay, well, what the fuck is this QB here, right? This QB1, 2 nonsense, right? So what is it? It's the shear flow between the booms, right? Which is this nonsense, right?
Okay, I think I'll USB-C right here too.
Here's another big important equation, and
Right here is for recharging.
you should recognize this, right? Because we've used it a lot, and whenever we have booms, we really employ this equation. And
Wait, do I need to do
what this is referencing, this is the boom reference, right? So for boom 1, 2, the boom of reference is boom 1. So we use the area of boom 1, right? Likewise, we only have the shear between boom 1 and 2, and we're not doing multi-shearing stuff. So we don't have this plus QSO out here that we would normally have, right? Don't have that. Not here, right? So we say, all right, well, we know Vy because Vy was given, right? Cool. Got Vy.
I think we can do 2 minutes.
So we have this. We have this. This is the Y reference, right? This reference is from the centroid, right? From the centroid to the boom, right? It's here, YR. I really wish y'all could see that. Look, that part. That's the YR.
How many
Garbage.
people are logged
I need a professional cameraman. That's what I need.
on? How many people are logged on?
13. 14. That's a good showing. Oh, yeah.
Did the studio setup behind.
I would love to steal the studio, but the liberal arts kids are in there, so they can have it for now. So we know this. We can determine this easily, right? It's just the centroidal distance from, or the distance from the boom to the centroid, however you want to call it. So that's that. So we know this. We know this. We know this. We have to find this. So we do IXX.
So what is the BR?
BR is the boom of reference.
Okay.
So the boom of reference
Area?
is the first one. Yes, the area. So this will be 10 centimeters squared. This will be 0.20 centimeters. Now, to avoid confusion, I'm not doing the translation from centimeters to meters, but do it in meters because that's what she asked for. So yeah, that's what we're gonna do. So then we need to find IXX, and since we have the booms, oh shit, there's a lot of you here. What's going on? I'm formerly known as Peter Parker. Formally, whatever. But right, so we have the IXX equation, and since we have booms, IXX is super fucking easy.
Here you go, Professor.
You're the fucking man. Hell yeah. That's what I'm fucking talking about.
All right, now start over.
Now start over. Fuck yeah. Start over. You can get on the live stream, run it back for a minute. We haven't done anything.
I brought
really.
you coffee.
All right, Batman. Here's where we are. Right? We did this. We wrote this first equation that states how the shear flow between 1 and 2 acts for our final answer. Right? So this is our first equation. We have the shear flow from the booms minus the shear flow from the left plus the shear flow from the right, because counterclockwise goes negative, counterclockwise goes positive on the left and right. Does that make sense
No, it's question 4.
or not?
On the negative.
Okay, so for here, when this shear flow comes in, it goes up. So that goes against the shear flow from 1 to 2. So we go negative. This one comes down, so that adds to the shear flow from 1 to 2. So we go positive. So that's where this comes from. Now this we can determine from this equation. And the only thing that we need to figure out from this equation is IXX. And since we have a really simplified version, since we have booms, we say that IXX is equal to summation of area Y bar squared, which gives us some fucking number. This. Right? And then we plug this in. This is in newtons. In meters? Newtons? Regular newtons. This is in meters. Make sure you run your conversions here from centimeters squared or centimeters to meters, right? Just don't fuck it up. It's really easy.
YR?
YR, the Y reference from the boom of reference to the centroid, right? Obviously measured positive from whatever axis you make. right? So then we run this, take this IXX, plug it in here, and we get this equals minus 12,500 newtons. I think. Yeah.
Wait.
So-
So what's the BRYR?
The BRYR, this is the boom of reference,
Yeah. What's the value for that?
the area.
All right,
So for this BR,
Oh.
this is going to be an area, which is going to be this area that we're referencing from the boom, which is A1, which is 10 centimeters squared, which is 0.001 meters squared. Right. So plug this in, get this. Hooray.
And then the YR is 20.
YR. Yes, the YR is it would be 20 centimeters, but obviously convert to meters, so you get 0.2 meters. Right?
Why don't you do the sum of both of them?
Because we don't need to do both of them, since we're only going from this one to this one and not from this one like around. Right? So that's the only one that we're interested in, and this is the one that we're starting with. So we only do the one.
Kitty, what is that? YR squared over 2 equals to.
Oh, that's a
Well-
scribble. That's an actual scribble. I don't fucking know what this number is off the top.
I'll try.
0.18 pi is what that number is.
Oh, yeah, you want
Maybe. I don't know. That's whatever that number is. Right.
I don't know why it's like, no, it doesn't reverse.
So now
It's higher.
we have our QB, which is cool, which now we need an equation for these. So please say, okay, let's take the moments about the centroid, right? So V, Y is 0. The shear flow from Q12 will be equal 0 since we're taking the moments about the centroid, right? So we have QSL and we have QSR, right? And from Bread-Bathot, we know that the moment created by a boom is equal to 2 times the area times Q, or the moment, the shear flow is 2 times the area times whatever section that you're looking at, right? So when we're looking at this equation, something that's important to remember, right, is that this area is not the boom area, right? This area is the area of this side of the circle or this side of the circle, right? So for this and this, the areas are going to be the same. So AL equals AR. So we get 2ALQL plus 2ARQR equals 0. Right? So you subtract over, you divide over, you get back, you get this. So QL plus QR equals 0. And that's our second equation. Right? So what this means is that eventually when we find some number, some other relation, actually we're going to use compatibility to find our other relation. That's theta dot 1 equals theta dot 2. But in this case, it's going to be theta dot L equals theta dot R. Right? Again, guys, sorry if this isn't super clear on the stream. I'm trying to say everything for you. So. No, I don't stream on Twitch, man.
So is that
So I don't play games. I really wish I had time to, but I don't.
is that MC equals 2AQS?
This is the moment about the centroid is equal to 0. And this is the
2AQ.
statement of what a moment is created by a shear flow. And that's determined from Bread-Bathot, which is in the book somewhere. It's on your formula sheet. All right, so what you need to know is that the moment from a shear flow is equal to 2 times the area times the shear flow. That's really it. So now we have to do this shit. So we come back here and we say, all right, theta dot L equals 1 over, now the thickness T equals T all the way through. So we can actually pull that thickness out because we have this 2A G T Q D S formula for the twist angle, theta dot, right? And we've done this a bunch of fucking times. So we do it. So we say A, L, Q, L, right? So when we look at this, we say, all right, so whatever's happening on the left side of this cut, we have going on. So we have QSL times its perimeter, which is the pi r, and our r is 0.2 pi. And we divided thickness out, so we don't worry about that. And then now we subtract. And we say Q12 times the perimeter that Q12 acts on, and that is 0.2.
The 0.2 pi and the 0.2 come from its respective area.
Nope, that's not 0.2, that's 0.4. It's 0.4. Right, so these are both perimeters, right? The length over which those Qs act. And this Q12 acts here. So this part of the equation is why I was saying that this particular problem is a little bit trickier than the other ones, because normally we'll have a shear flow that goes all the way through, and then we'll have a relation that goes here, right? Like it would have been QL minus Q2 or something. But since Q12 is the only thing that acts here in this beam, we don't subtract it from the QL. Right? So don't mess that up. Yes, the 0.2 is the radius. So we get 0.2 pi. So then we write theta dot r, 1 over 2a r g t q s r 0.2 pi plus q12 0.4 as so, right? So on the left, we subtracted the shear flow from Q12 because they're going against each other. On the right, we added the shear flow from Q12 because they go together, right? So now we have, from compatibility, theta dot R equals theta dot L. When we do this, we end up with QSL minus QSR, 2.2 pi, plus Q12, 0.8, 0. Because algebra, right? Everybody can do that. Am I open? But now we have this equation that I was talking about that related QSL and QSR with Q12, right? And for that, we need that other equation. This This is the equation that we were going to substitute in to solve compatibility correctly so that we can A, get a number, and B, solve the rest of this bullshit. So we do it. All right. And for Q, everywhere we see Q12, we substitute in this bullshit. Which gives us, sorry, give me just a second. I'm sure I did. I am sure that I fucking did.
12,500 minus QSL plus QSR total.
Yes.
True.
Once we make this substitution into the other equation, we end up with QSL minus QSR equals 7001.33.
QB12.
And then we
Okay.
plug this equation in and we get right. And then once we have these, plug into right here, and we're done. And it's really just as simple as that. And then that will give us the Q12, right? Once we plug it into here, which is 5,498. Right?
You get the 12,500 from
We got the 12,900 from the summation of moments about the centroid.
What about the QSL minus QSR equals 7,001?
Compatibility. And the substitution from this. The equation that we wrote to describe the shear flow from 2 to 1, or 1 to 2.
I'm still not seeing that last word.
This?
No. Oh,
This? Okay. I'll write it up then. So when we do compatibility, we have this, which gives us 10,000 plus 0.8 QSL minus 0.8 QSR equals,
what's the 0.8? Oh.
the 0.8 comes from the perimeter, right, of the Q12, right, because here, this is Q12, and this is the substitution that we're making, so that we can get everything in terms of QSL and QSR. Huh?
Shouldn't that be 0.4?
No, 0.4 plus 0.4 is 0.8.
Oh, because you're taking like, it's almost like a rectangle and you're taking the left side and right side of that.
Yes, yeah, right. So when we wrote this equation, right, we have a Q12.4 and a minus Q12.4. Since they're on opposite sides of the equation, they're going to add together, right? So we get here, and Christ, try my signs backwards. I might. Nice. Yeah, because this should be when we get this over, we get QSL minus QSR, 0.2 pi plus 0.8 equals 10,000, and then we just divide that over, and then we plug into this formula, and then that's where we get the plus minus 3,500.66 repeating. Makes sense, right? For those of you that are actually doing the math, did we keep our signs right the whole time? Maybe, hopefully. I think so. Yeah, we did. So from here,
Wait, Q1
what else?
should be negative, I think. at the bottom.
Q12 should be negative. It is. This is negative at the bottom. But the point is, these should all add together. Be careful with your signs. Like really, really careful. Because I feel foolish up here because they're not matching up the way they're supposed to. But they do as long as you keep everything straight. From here, once we have Q12, I'm pretty sure that is all that this question asked for, isn't it? The complete shear flow. Because then we have QSL, we have QSR, and we have Q12.
Yeah.
Yeah, so that's it. We don't need the angle of twist. We don't need torsional rigidity. We don't need any of that. We could say that stuff easily by plugging in some of the equations, which are on your formula sheet, which is easy stuff. Right? I use brain in the front. But that's all of this equation, or all of this problem.
Yeah.
Thoughts, comments? Did I not cover anything? So, big takeaways, right? Right, so we write an equation for 1, 2. We make the cuts and write a moment equation about the centroid. We write compatibility. We solve. Once we have the theta dot compatibility equations, you should be golden, right? I think that covers it.
The camera slightly.
Yeah. So what do you want to do next? Problem 3?
There. Like, that's basically it. Yeah, it was already.
Which is this fucking page? Jesus Christ. Got this. Got this. That is fucking idiot.
So the very last step of the last one, are you just solving QSL and QSR in terms of each other?
Yes.
Okay.
So once
They don't need
we
to actually
wrote
solve
the
them
moment
individually.
equation, we got a relation for QSL and QSR, right? Because we let the shear flow be equal to 0. We let with VY, the moment from VY was 0. The shear flow from Q12 was 0. So those were the only things. So we got a relation for that. Then when we did compatibility, we got a relation for QSL, QSR, and Q12. So that's why we had to write the Q12 equals QB12 equation, right? So that we could substitute that in so we could get everything in relation for QSL and QSR. So we only had 2 unknowns instead of the third.
So are you getting numbers for QSL and QSR at the end, or are they in relation
Yes.
to each other?
Yes, we got a number for QSL and QSR, right? So we got the big number for QB12 from
Was like 12,500 or something like that. Yeah, I got that.
That's essentially what that equation was to get this number. Yeah. Which is how we got that. Fun stuff.
Yeah, I get it to when it equals 7,000. I'll put that.
And then you put in the QSL minus QSR equals to 0, right? Or is it plus? QSL plus QSR equals to 0. And then you solve, right?
I'm not 100% sure where I have the iteration of this work that I like.
The next step after you get done equal to 7,001.
Yeah. So we should have and then we got this from some other bullshit. I don't know what the name for that equation is. This one. I don't know what that equation's name is, but that's the one that we use to find this. Because that's the only equation that we can use to get a number to solve for all this shit. Otherwise, we just have stuff in terms of variables, which doesn't solve anything.
What I'm asking is what's the very last thing you did after you got QSL minus QSR equals 7,001? The very last thing you did after that?
Plugged in this
Okay.
so that you would only have one unknown. So
Alright.
you would get a number and then just run it back real quick and then you get all your other numbers. Realistically, if you have a TI 89 or are competent using a calculator, you can use your matrix solve or your solve function or whatever once you have all these equations. Plug it all in and go. That way you don't have to do any math on your own. That way you don't fuck up your signs like I do. Yay for fucking up. At any rate, so now we have this dickish looking problem. And we have a bunch of different T's, right? T1, T2, T3, and T4. Right? That's T3 for all those and T2 there. So here so this is problem 3 from the review. Notice we have areas, we have shear flows, we don't have booms, right? Which means that when we do IXX and IYY and IXY, we're going to have the base height third 12 plus AY bar squared. For this, right? And something to note on this problem, right? Really, whenever you're doing stuff, look for symmetry, right? We have a little bit of symmetry here, since we can go along the center line, say that the top is equal to the bottom. So IXY equals 0, which significantly simplifies our calculations later. Nope, that's for sigma z. That's not even this problem. Still, recognize symmetry in your problems so that when you end up using these equations, you don't solve for IXY and waste a bunch of your fucking time. That sucks. So here we're looking for Q1, Q2, Q3, theta dot, and J. Right? So we know that we're going to have compatibility, theta dot 1 equals theta dot 2 equals theta dot 3. From here, we get one equation, we get two equation. We have three unknowns, we need at least one more equation. We're going to use Bread-Bathot. The torsion is equal to 2A1 Q1, etc. And that's going to be our third equation. Using these three equations, we've got everything that we need to solve for these three shear flows. Once we have the shear flows, we can solve for theta dot, the rate of twist, and then we can solve for J. So both of these are dependent on our ability to find these, right? So easiest thing to start with, spread Bathot, which is T2A1 Q1 Yay, real easy. From this moment onward, this problem gets really, really gross. Like, disgusting. So, forgive me for not doing it offhand. I am going to copy what I've previously written down, just because of the amount of errors associated with doing it is pretty high. If I can find my word. There we go. So, when, like before, right, we have shear flows that come and mix with each other, right? In this instance, the shear flow is acting all around the perimeter for both sides because we don't have any booms, right? So, we're going to have Q12, Q23, Q21, and Q32 as things that we have to take into account when we're running this. Now notice I didn't put the T outside on this because the thickness is changing. And wherever the thickness changes, you have to account for that in a different way because you're dividing by a different number, right? So, like Sitha said in class, Q12 is Q1 minus Q2. Q3 is Q2 minus Q3, etc., etc. And of course, right, the line integral with EAS is always a perimeter. At this point, it should be automatic. You shouldn't have to think about it. I hope you don't. I hope I don't. But anyway, theta dot 1. Right, this. Then we have the perimeter that theta 1, or that Q1 is acting on by itself, which is half of this circle. So we get Q1.5 pi, 5 pi. These meters? Inches. Yeah. Whatever, we can do 7 inches. Right? Divide by whatever T1 is, 0.0025. And then plus, now here's the part where normally we would write Q12. But since we have Q12 as Q1 minus Q2, that's what we write instead. So we say Q1 minus Q2 times 10.05, I believe, right? Because here, this perimeter, this length, whatever, is 10. So we write it as such. If you leave it like this, you might make a mistake. So I say at this point, excluding this part out here, simplify this as much as you possibly can, which will leave you with
Yeah, you assume where it's at. So you do right smack there. And then, that's how you do it.
that. Right. And if you have it as just simplified numbers when you're running your equations, or when you're writing your equations, you can plug it in a more simple way. Because if you leave everything in, pi and times this relations, it's messy. Unless you want to, but the more put together that you are about the work that you do, the less mistakes that you're going to make. And little mistakes are going to be the kryptonite of everybody in this class, because there's a ton of steps. There's a lot of places to make some dumb mistake, forgetting a sign or a piece of an equation. So we continue, right? Now, for theta 2, we have the most complex equation that we need to write. Theta 2 only, or theta 2, Q2 itself only acts in the top and the bottom, right? Theta dot 2, 1 over 2, G. And we have Q2 is 20 over T3 plus over T2 times 10 plus right. So again, simplify this equation as much as humanly possible, so you don't have a bunch of bullshit to deal with.
Yeah, but when we were 39.3 is going to give you 2.1.
Right. So we all get that though, right? And it's follow this method. It's just tedious, right? It's not hard. There's nothing hard about it. How much is going here? This much. How much is going here? This much minus this much, right? That's it. And then you write your third equation. Then you set one equal to the other. Theta 1 equals theta 2. Solve. Theta 2 equals theta 3. Solve. Right? Once you have the theta 1 equals theta 2 equation, that's one equation, right? And theta 2 equals theta 3, that's another one equation. Then you have 1, 2, come back up to your third. You have your third equation. Now, plug it into your calculator. Let your matrix solve it. Let your solve function solve it. Whatever you have, let that solve it. Because why not, right? Like we have the capability to do it, so make it easy. So then we get some numbers for our Qs.
Oh, I made it backwards.
Now, once we run our equations, where are they? Oh, there we go. So when you do the algebra, you should get Right? Plug it in, solve it, and we get if you're looking at the review versus my answers are a tiny bit different than hers because she rounds in ridiculous ways that don't make any sense to me. Like at the beginning and randomly on the way through. I don't get why she rounds like that. I don't think it matters if you're off by 1/10 or 1/100th. But from here, right, we have all this, so it's just plug and chug. And J is this. And for theta dot, you can plug these Q's into any of your original equations, right? Into any of the original theta dot equations, this one or this one. You can plug your Q's into that. Doesn't matter which one you do, you will get the same answer, right? Does everybody know what units we get when we run the regular theta dot equation? No, the units for this one are radians per meter, right? So if she asks for degrees, remember to switch it. And then this is just that. Be careful about your units. Make sure everything matches.
No, what you solved.
Sorry, I can't hear you. Oh, yeah. So we were given an E and a Poisson ratio, right? Everybody remember the conversion from Nina's class? Right? G equals E over 1 plus Poisson times 2. Yeah. So this is the modulus of elasticity, and this is the modulus of rigidity.
Times 2 is on the formula sheet is squared.
That's right.
It's times 2. It's times 2.
Formula sheet is squared.
Yeah, no, it's times 2.
I'm guessing.
Yeah. Okay, so
Go right against it.
definitely this G, right? Don't fuck up this equation because you look really silly getting everything else right and then getting J wrong.
For what? It's 2.
Yeah, it's 2, not squared.
No, he's asking.
Yeah. Yeah, I'll say. I think I know what I'm doing. Pretty sure.
You get theta just by putting theta 1 equal theta 2 after you solve.
No. So when you're solving for theta dot in the end, you pick any one of your theta dot equations, theta dot 1 or theta dot 2 or theta dot 3. Plug in your Q's, whatever number you get. For this particular problem, you get 0.000222 or 221. Yeah. 221, etc. And then you're done with that. And then you take that same number and you plug it in here along with this one, and your T was given, so plug and chug. Once you get here, once you get these 3 equations, right? Compatibility and Bread-Batho. They're your best friends for this whole exam. So use them. They want to be used. They're easy. Just like you.
Wait. Are you Haywood?
That guy.
Yeah?
Just like this guy, man.
Trying to hide from you for so long. God damn it.
Yeah, from the
Anyway,
comment.
Christ. Oh, fuck his knee, Jesus, I swear. So what else do we not understand? Or what is like kind of a pain in the ass? That way I can make this more interesting for y'all. or at least more relevant.
Do you have the Q values just so I can see if I did it on the calculator?
The Q values,
It's
yeah.
Q1 1433.
Yeah,
Okay.
right on that.
Oh, I opened my eyes. Wait, it's 143.3?
Yeah, it's 143.34.
Oh man, all mine are off by 1 decimal. I'm gonna kill myself.
You know this process?
The one from the homework?
IXX. You want it?
Yeah.
I need to wash my hands, don't I?
Huh?
I need to wash my hands, don't I?
Yeah.
You have the question?
Oh, I don't have the question.
Yeah.
Is there a specific thing from this?
It was the IXX.
It's an elation.
Like, has that sign squared in
It's
there.
an elation.
And I think the next problem too had, at least on Shear, the IXX was like over 3 and there was some stuff. I was confused. Are the other ones?
The first key one?
I don't fucking know. I don't know why they're using sine squared alpha. Okay, let's see. Singly symmetrical, thin-walled cross-section with no booms, right? Okay. So we do the same thing. What is this?
The G's
A and T.
T.
Well, I haven't done for the two. Combine it. I'm sure he combines them.
So for this,
Oh.
right?
Were you just copying?
No. I was
No.
no, I just do it all in one.
Why is it all off by power?
Take
Not
it
bad.
No, I get everything off by power 10. Should take my grade off by power 10.
That's funny. What the fuck is this? Y bar squared? Right. So where's the centroid?
What are you doing now?
1, 2, 3, 4. This is one of the homework problems.
I can't see.
Yeah. This one sucks. We're not gonna have a problem like this on the exam. So everybody knows. Sorry, what? Yeah. It's gonna be, her exams are notoriously exactly like her reviews. They're pretty much almost 100% the exact same questions, except just a little bit different on the numbers.
All right, we get shit like this tomorrow. They're coming after you.
What? Fuck that, no.
Is different enough last time for me to see.
It wasn't.
Don't do it.
Well-
Don't skip it.
We'll get that one.
Yeah.
This will be our protest now. This.
We'll storm the nearest
But
chevron and
It doesn't really necessarily matter
It
though,
doesn't work.
because we can do the same thing. The base,
for chevron. Yeah.
it's gonna be the base, and the height's gonna be the height. So we do it just like every other problem, right? Section, base, height, and we make this little table, right? If you make the table, you're not gonna fuck up, at least on the IXX, right? Does anybody ever make tables when they do it, or is that just me?
Absolutely not.
Absolutely not. Okay,
I
well,
did on Monday.
if you make tables, you won't fuck up.
No, I'll fuck it. I'll find a way.
You might find a way to fuck it up, but only you. Honestly, the reason why it's sine squared is it's a geometric relation.
Right. Well, when I worked it out, like, you get a sine for the height, and you get a cosine for b, base. And I mean, it wasn't adding up to what they were getting. So.
You had me saved, but that's not what
I got like base is a cosine alpha. Height is a sine alpha. Cube one of them. You're gonna have sine cube times a cosine. I think.
I'm not 100% sure, actually, how to explain why it is like that. Sorry. I'd like to be able to explain everything, but I just kind of suck sometimes. So I don't know. I really don't know why that's a sine squared alpha. When I went to, I think Blake, the guy? Yeah. He was like, because. Yeah, his answer was because. So that just sucked. Yo. Old exam problem.
Oh yeah. That's all one.
We just did this one.
I guess I'll find out.
Yeah, what's that?
Two thin wall across, except this is a different one. There's no booms. So it's
I kill myself.
this same problem again.
Where do you get that from?
No. Wait, is this
I
just
know,
without
is it
idealization?
like a former exam secret or just former easy?
I don't know. I haven't done this one yet.
Well, you got a secret safe.
So you got them.
Yeah. Like you love my online
Did you get the first couple right?
Yeah, I think I got like 5 of the 6 multiple choice right.
For some reason I was just looking at it like geometrically, just added the parameters of the.
I actually like that one.
I'm waiting for this to be like a cast of
Dude,
calculus.
it's full of
I just did
Once
things
it
like I don't know.
once
The
it hits
numbers
your
were
lips,
like bad. It's just-
you know,
Yeah, I like they included those so that you could
I don't like
first
that.
the right answers. But like what I used and then like what I saw.
Okay.
But see, those were both on
That's
there, so I was
weird.
like, good, like got it, and then like after.
Most of mine are all like definitely not doctoral.
So what do they want us?
Between 65
They want us to find.
Okay, I have to take my bullshit.
Okay. So this is a problem from an old exam, and it's going to work very similar to the other one that we did, right? So we have compatibility. We have theta 1 equals theta 2.
wait, was that all the exam solved?
Is this a 2004 one?
I don't know. It's the one that he handed me, so probably.
Is it solved?
No, of course not.
This is 2012.
So we have compatibility. We have red bathtub.
Not that I would know.
So what is it asking to find?
Was 2012 test one very similar to 2018 test one? I thought you would know.
It actually was.
Maybe we should go over these. Actually, I had the 2012 test one, but we didn't show pictures. I remember talking about like structural failure, and I remember that being yeah.
Oh, for the flight envelope?
Yeah. So I think it might be.
So we already have our 3 equations, right? We look at it and we say, well, the shear flow through 1, 2 is going to be equal to shear 1 minus shear 2, right? And we know compatibility is this side, right? Theta dot 1, area 1, G, and
What does theta dot say? Oh, like 3 degrees. Is theta dot?
well, we have to calculate the shear flows
is that 3
because we're
degrees
given
per meter?
a
C.
theta dot at 3 degrees per meter, which we're going to have to convert into radians in order to give us something useful. But once we write our compatibility equation, right? Actually, we could do it with just this. That? No, maybe. Yeah. Once we write our compatibility equation, right? Theta 1 equals theta 2, and we can solve it. That'll give us this, right? Because both of these are going to be equal to 3 degrees per meter. Actually, we could straight up just write the twist for this and then the twist for the other one, solve them simultaneously as being equal to 0.3. I'm sorry. Right, it said 0.3, or was it 3 degrees per meter? 3 degrees per meter, right? Actually, we can solve this right off. This is an easy one. Thank God.
You say that.
I say that, but like it is.
Because it's just one equation, right?
The shitting
Yeah.
review.
Or 2 on the torque.
Yeah,
So that's just the 2 by 2.
yeah. All right, and then since we're coming into here for Q12, we know that Q12 is equal like this. So we get times, and that's 50.5 meters, and T12. And then we have theta dot 2. Yeah.
You check.
And then we set both of these equal to set our conversion to radians, set these equals simultaneously. That'll solve 1 and 2, which will solve our third, which will give us our torque. Once we have our torque, that'll give us our J also. Since we already have the angle of twist, right? And once we solve these two equations, right? Because we have 2 equations are equal to something, right? 2 equations, 2 unknowns. Done. Makes sense why we add here and why we subtract here? Right? Okay. Cool. Yeah.
Yeah.
Because this adds and this subtracts. Right? Just like shear current flow from principles of VE. It was given. Yeah.
So that's pi over 180 times 50.
This is pi divided by 180, the conversion from degrees to radians.
Are you converting
Because-
right now or no?
Am I? Well, I don't. I mean, here, once we get to this point, right? It's just solving the equation, right? So we have 2 equations and 2 unknowns. We've solved that a million billion times. So I don't feel necessary to do it right now, unless you guys want me to. No? Okay. Are you cool with me leaving this in a
No.
equation form versus solving for the actual numbers?
Yeah, that's fine.
Yeah, okay, cool. All this makes sense?
When you get the Q1, the Q2 after you set them equal to each other, what's the equation you balance that out with? Like,
Well, we were given this, so we actually didn't need to use compatibility at all. So we're given 1, 2, solve for 3. Done. Equation 1, equation 2, equation 3.
and then you make a matrix.
Yeah, this is just an easier version of the problem that she gave us.
And then you make a matrix out of it.
Yeah, make the matrix out of it, put it in your solve function, do whatever. Don't do it by hand. You'll waste your time.
Do you want to do another problem?
Yeah, I can do whatever problem you want.
This one about shear sensor.
One about shears.
I
Of
passed
course.
about 84, but Dad,
This stupid fucking bullshit.
It's
Yes.
Why
you showing me how to do it?
No.
Um,
I haven't even looked at the news that much.
See if I remember.
It's all the news I need. Well, it'll be so much better than what my model is. Yeah. It was like tiny set this.
okay, so immediately when we see this, we see that we have sectional shear flows. QS equals minus Vy over
These
Ix.
were new.
Yeah, this is coming new.
This. Right? We're going to use this equation. So when we do this, right, we make a cut to here. Then we'll solve for minus Vy Ixx. This is our reference, right? So we have the area of boom 2, which is again, we have booms, we have symmetry also, right? So
What was the problem we used that used the same shear flow equation but without the QS?
that was this one. The
Why
one
didn't-
just like the one that we just did, but it had booms
Why
instead.
didn't it have the?
Because there was only one shear flow between booms that we were talking about. This one will have 1, 2, we'll have 2, 3, we'll have 3, 4, we'll have 4, 5, or 4, 1, whatever. Right? And since we have it compounding, one section after the other, we're going to have to add the shear flow from the section previous to the new thing, right? Because this flow doesn't stop just because there's a boom here. The flow continues to flow. So Q12 feeds into 2-3, which feeds into 3-4 and into 4-1, et cetera, et cetera. So we have to remember to include the shear flow from the section previous to the one that we're working on. Right? So given
Dimensions for this,
I got more.
I'll need your mom.
all sides are of length L and all lengths are of 40 centimeters. And Vy, Christ. Sorry, this is so messy, guys.
All the lengths of the thing?
Yeah.
How are the periods?
Hmm?
How are the areas different?
Because those are the boom areas, not the area of the thing, not the area of the shape. Those are these ones. Right. This and this are equal. This and this are equal. We've got nice stuff. Oh, Christ. Each side has length equal to 40 centimeters. So the total would be 160.
Peter, you want to do my exam? I'll pay your rent.
My rent, shit. That's an interesting offer, but unfortunately I have to decline. Academic integrity and all that.
Ask
I'll
them
say
again.
goddamn white people and their academic integrity. Hell yeah.
Ask
Fuck
them
with
again
it.
with strings on.
That's like one good reputation that we have. All of our other reps are shitty.
Just ask them again. No, it's not on camera.
The fuck. Okay. So okay. So we're going from 1 to 2. I made my cut at 1 to 2. So that one's 0. You're not. We say QB 1 2 equals 0. So now we come here. We say QB 3 4. Or no, not 3 4. 2 3 equals minus BY over IXX times the area of the reference, right? Which is B2, which is times the distance to the centroid. I didn't do the centroidal calculation yet, but it's a square, and the area is on the top. It should be 20, but
Doesn't have to do with the boom area. Though?
it does. It does have to do with the boom area.
What's the value of A2 and A3?
A2 and A3 are 1 centimeter, and A1 and
I
A4
see.
are both 2 centimeters. So it should be right there in the middle. But
Wouldn't the boomerang also stop though?
Wouldn't it be to the,
Actually,
to the
well-
right? Yeah.
to the right. X would be right, but the Y would
Yeah.
yeah, the Y would be in the middle,
Yeah.
right? Which is the one that we're looking for
Oh,
right now, right? Because we have a Y reference. So this should be 0.2, right? And then for solving for IXX, we only need the Y centroidal area. And then, yeah,
should be 0.02.
20 centimeters, 0.2 meters.
Oh, okay. My bad.
It's not millimeters.
I saw the 2. That's my
Yeah, no, you're good. So then again, like before, we have this shite little equation, and the only thing that we need is IXX. So we plug in and solve for IXX, which is whatever IXX is. So then we'll get QB equals some number here, or QB 2 3 equals some number here. They say, all right, well, QB 3 4 equals minus VY over IXX times, again, the area of the boom of reference, which in this case would be 3, which is 0.001. Wait, yeah, meters squared times the Y reference here. Our Y reference here is negative, right, to get to the 0.3. So it'd be minus 0.2 times minus 0.2, not minus 0.2. And then, because we can't forget it, because we have this fucking part, plus QB 2 3, right? From here, we have the shear flow from the one previous. Now, at this point, we would have already solved for IX, for IXX, so we get another number. Say QB 3 4 is whatever. And then we go again, and we get to 4 1. Then what?
Is it really 0.001? Yeah, it's off by 10.
I think it's
Okay, 0, 0, 0. Thank you. Good catch, right? So then we go until we have all of our QBs. QB 1, 2, 3, 4, 5, all that shit. We say, all right, well now we need the summation of moments about some point on this figure, so that we can figure out a number for our idealized constant shear, the one that goes through everything, right? Oh, Christ.
Does that have a name like the constant shear? Is that QS? Is that one of the QSO?
Yeah, that's what this QSO represents.
Oh, okay. That represents all of them?
Yeah.
It is asking for even shear flows from the location. Shear center.
It's only 7.
Showing why the shear center represents.
It's like it's 2 hours, right?
Well, I feel like
Shear
it
center.
sounds class. That doesn't indicate.
I think we can use this full equation, the v minus vy divided by ixx times the sum of all of these areas to be equal to this to get your actual shear flow constant. And then you use your QB forms to plus your QSO to solve for your total Q1, 2, 2, 3, 3, 4, 4, 1. And that'll give you all of the shear flows through the entirety of the figure. Then, once you have the shear flows, you set a moment equation to solve for where the shear center is. So you have some loading Vy that's applied through the shear center, right? So we end up with and this E locates the shear center. So we pick an intelligent place to set our moments about. So we can either do 1 or 4. Either way, it will cancel 2 of these. And we do summation of moments. We get Vye equals Q23 because 4, 1 and 1, 2 will both go to 0. We take moments about 1. We have the moments from the shear flows. We divide over by Vy. We get E equals whatever the fuck this is.
This is from the news?
Hmm?
This is from one of the news?
This is from an old exam.
Can I see it?
This one's solved.
This one looks pretty shitty.
Yeah, this one is pretty shitty. But it's no shittier than anything else. You just have to know to go one step at a time, right? Get all the way through, then go back.
The total age of
Hmm?
the section.
This is going to be this area or this area,
Okay.
right? So it's the area of the boom. Still.
Why don't you use 1 and 4? Or why don't you use 4, 1, 1, 2?
Summation of moments at 1,
Damn, I think I'd rather
right? So we pick whatever simplifies this equation the most. I mean, theoretically, you could do some midpoint between 4 and 1, but that'd be a pain in the ass. So don't do that. I'm not saying you can't, you just it sucks.
So why don't we get
Alright. 3. Yes and no, right? So this E is referencing this line 4, 1. So you want to pick one of those spots. Just because otherwise you'll be measuring a different distance and then you'll have to go back and make sure that you correct for that. Right? Christ. Good stuff, guys. I like that question. Any other ones from the old exam you want me to do?
Josh, stop memeing.
Alternative.
Yeah.
Where'd I put that exam down?
It's a lot where someone kills himself in the middle of the exam.
Who'd I give the exam? Yeah.
It's a bad feeling.
Do you want to take
At
one?
the moment,
Nah, fuck you guys.
times
You still have a gun, right? You still have a gun, right?
Yeah.
Yeah, from your army days.
The shear.
I think they let me keep my.
Times 2.
So I was never yours.
So 2 times the area
I just want to
times the shear. Because the shear flow is in force per length. So in order to get to force times length, we have to multiply by area.
look. I just want to get shot.
If I still had it,
True.
I would bring it with
Is it
On
3?
campus. See the students we have after.
I don't care. I just want to die.
you. See me walking in the library.
Yeah. Okay. Oh, this one's nice. I like this one.
The fairy killer.
No structure. I need to steal these mud from
Go ahead, man. Like $16. No, so-
$16. What? The nose pads.
I never even pissed on it. I think I like sat on them once. It still works. I know.
The nose doesn't go like that. It goes like this.
Yeah, I know. Hot as fuck.
I am hot as fuck. Thank you. Need to get my glass.
Wasn't this one of our CFUs?
Huh?
I feel like this was one of our CFUs.
As-
Fine. And I mean, man.
So I'll be me and Siva tomorrow.
Given the centroid as marker. Okay, so this is.
I'm gonna throw my exam. The notes in your physics 2 folder. It's 7:30 like right now. Close enough. You get in bounds in 4 minutes. What the frick? Just like you wouldn't go down the steps. Like you would smash out glass.
Absolutely fucking smash mouth.
I zoned out.
It's in the group chat.
I'm still in the same place. My phone's there distracting.
Once I like it'll be live until we're done, and then it'll automatically upload once we're done. After that,
One of you guys.
unfortunately, it's gonna be super shitty to watch because it's a live stream of me doing this bullshit in front of you. Okay, so for this, yeah.
So like, what's the difference between A and B then? Find Q23.
So this is the basic flow, which is equals whatever. Right. So it wants us to find the basic flow and this as separate things. Right? Finding this and then finding this. And then using this and this together, it gives you this. And that's from the last homework that we did, maybe? 8?
Also the last year.
Yeah.
Work.
Yeah. Are we given a VY? Oh, so in the problem statement, it tells us TD equals 0. And that might sound like something that's useless, but it tells us exactly which equation to use, which is the equation that shows up with TD in it, which I don't know off the top of my head right now, but it's in the formula sheet.
Where's that?
I believe so, yes. Yeah, that would make a lot of things 0, which would make your overall calculations a lot easier. And then again, it's remembering that the flow from one flows into the others, right? So you have to add and subtract as necessary.
That's the vertical thing.
What is TD?
Sorry?
What is TD? Wikipedia shit on the map.
Thickness of something.
It equals 0.
Yeah.
Is that given in the?
Yes, this was given in the problem, which pretty much tells us exactly which equation to use, which is the only use that I found for TD so far, since I don't remember what it is exactly. And I don't think we've had a problem that we actually have had to do where TD is not 0. So
It's gonna sound pretty bad this late, but what is the equation for QSL? Like, or how do we find the QSL?
no, that's a good question. I'm
Is that
just
for moment?
being an idiot currently. I think that's the moment equation. Yeah. We end up solving QSO through the moment equation. Take the moments about the centroid.
Can you make an example?
Huh?
Can you do an example?
I think it's CFU 12.
CFU 12. All right. Can you put up CFU 12 now?
Yeah.
He says these things like moment. As if I learned lazy in steps.
Right.
I had industrial electric. I'm bullshit the exam. Yeah, always. That's what getting all these weird people. They can fucking conquer names. They're broke.
Alright, so we're going to do CFU 12 and then we're going to do problem 2 from the review because somebody online is asking for it.
What?
Problem 2 from the review, which is fucking, I don't know what problem it is.
That's the.
On this.
We went over that a little bit.
Did we?
We kind of went through it fast.
I don't think
That's where you just plug in all the.
I thought we did 3 and 4.
Yeah, we did 3 and 4, I
It's
think.
the stress of the mover. Right? Did we go? I thought we just like wrote it out and it was all just plugging in so we realized.
It basically is. Oh, this fucking problem. God damn, I hate this.
If you're gonna take requests from the live stream, tell them they need to donate your Patreon.
Listen, they do need to donate to my PayPal.
Just drop your Venmo in there.
Good luck, guys.
That's not you.
Move here. You can't see over there.
So that's it. Just like find the equation.
No, I don't have that. I'm gonna laugh when I do 10 points better than you on the exam when you leave right now.
What?
If you leave right now, I'm gonna laugh when I do 10 points better than you.
No, you won't.
Leave, El Diablo.
What?
Leave. Go home and sleep.
I can do 10.
I'm not gonna go sleep. I just need my calculator. I'm coming back.
Are you coming back?
Yeah. No. Yeah.
This is the no sleep zone. So, what is this asking us? The fuselage cross section of a wing cutout is some bullshit. Fun.
See that so much.
So listen, just like good job, you'll find whatever.
Yeah, she's like, you're plugging in these estimated flows into,
Oh, back up.
Oh, so then it's yellow beside you.
2, 3, 5, 6.
So you just gotta do some analyses and that's it.
I think it does the analysis.
Yeah. Pretty sure everyone's playing with that. I'm afraid to go crash and be like, I'm not gonna tell you.
So she is what? I missed 2 classes, but
So cross section cut out idealized as shown. Boom area is equal A. Okay. So
Oh. Yeah. I feel like that's it for this one, but I don't remember. Unless that was one on Tuesday. I missed it.
Later, birdies.
bye. So why do we have both areas, guys?
Because
As
there's
if
smaller
I know.
sections.
Yes. So we have boom areas, and then we have areas enclosed by those booms, which we'll need at different points throughout the problem that we're doing, right? So first things first, we do an equation of we do an equation of what does it matter? Moments, right? We do moments about the centroid. From here, Vy is 0. And what's our equation for moments of stuff with booms? Very good. 2A12. All right. So for A12, we get QB12 plus QB61 plus QB34 plus QB34 and 45, right? Conveniently, this goes to 0 and this goes to 0 because, hey, look at that, they gave it to us and it's 0. Plus 2A23, right? Now these are the areas enclosed by these shear flows. And now we have the others, right?
Why is the moment about C Vy 0?
Sorry, what?
Why is some of the moments about C Vy times 0?
Centroid. Vy acts through the centroid.
Ah.
Yee. Why is it? Because shear acts through the centroid.
Don't mind me. I'm retarded.
No, not you. Somebody else on the chat asked the same thing. Yeah.
Ah.
If
So,
you're using the areas of 1
what's
to
the-
2,
Mhm.
why do you have to put it
What's-
on QB, like,
Because this area is equal to this area is equal to this area is equal to this area, right?
Alright,
So this area, 5,
why
6,
is my number so small?
and 2, 3 are going to be equal, right? So So we get some equation for this, right? Wait. Yes. Plus QSO.
That should be like 333.
And that's multiplied by the entire
But
area.
then you could multiply by 1 over 8 too. 1 over 8 is
Eventually, you should end up.
Yes. Yes, it is. Right?
what do you get different?
Because the idealized area acts all the way around it. Right.
Two.
And we, in the instructions for this, it said to just assume that this closed,
So just the area of the whole.
right? So it'd be the area of the whole circle. Since that idealized shear flow is constant and it has to act through the whole thing, it acts through the entire area enclosed. So we get plus 2SA, we'll call this T total, and then we simplify
That's why it's easier to set
this god awful
that and not equally try to line
setup here.
because then
Right.
stuff starts canceling out.
Fuck, y'all can't see a damn thing.
I felt that.
Sorry.
I realize there's so much more to know.
So we simplify this, right? We have all of our respective shear flows in their respective areas put in here, and our unknown shear flow, our total area. So all this goes, and we get when we solve for QSO.
What's that second area say? Does that say 2 to 3?
This is the area of 2 to 3, yes, right, which is the area between here.
No, wait, no.
No,
I'm
it's because
But
it's
wait,
2 times the area times the shear flow is the moment.
So
Right,
what
since
about-
we include all of this in one thing, so since this 2A whatever is going to be the same for all of them, we just hold it out.
So what happens with the other ones that it's like?
That don't cancel to zero?
Never mind.
Well, the things that don't cancel to zero, we plug in what their actual values are from up here. And then we get down here. And we solve for QSO equals,
Are we given V1s?
that. Yeah, we're given VY. VY is some constant, I think. Yeah, VY is some unknown constant.
So
But
just-
it's a constant, so it's,
so leave things in terms of these.
Yeah.
Okay.
so then once we do this, we just add this, right? We get Q12 equals QB12 plus QSO. Dot, 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 dot. Solve, done. Again, it's a moment equation, super important and useful, and you're gonna use it all the fucking time.
And
So get used to it.
and how do you get QB if 1, 2? Or is that a given?
Given.
Okay.
All of the QBs, the
Yeah.
basic shear flows were given.
Know what the B stands for, basic.
Yeah.
Ah, sweet.
Breakthrough.
Like the R stands for reference. And then the BRYR formula. The boom of reference, the Y value of reference.
I'm wondering what the letters are. That's like
I'm pretty sure that's the whole thing for this, isn't it? Yeah.
we didn't do number 1 and 2 off the review.
Yeah, we're gonna do 2 off the review now. Yeah. Oh, this son of a bitch. This is the reason why I told Dunce to put the positive notations. Yeah. Okay.
I spent forever on the equation.
I screamed when he told me to look in the book, and I saw it was like, oh, clockwise is positive. Cool. I'm gonna just go fuck myself now.
I kept getting one negative.
And one positive, and you were like, what the fuck is going on? Yeah.
You just got to find them yourselves and make sure you write that down, which takes points off. Like, hey, look right here.
No, you're fucking positive sign notation, or you're fucked. Or, it's on your formula sheet, so
So
look on your formula sheet. Either way.
Where is it?
Backside.
So clockwise probably.
Oh, the sign.
Which way is positive depends on which professor you have.
I have professors that they're totally fine as long as you put the notation.
Yeah.
Counterclockwise is whatever, as long as you stay consistent.
Yeah,
Yeah,
so
sure.
static
This is
for
how-
In my opinion, counterclockwise is always positive.
Same.
But clockwise is
It's
fine.
like,
For only one of them, it's clockwise.
yeah, for M1, right? M1, you go like that, so you go down. She says that's how aerospace is. Aerospace is retarded.
Do we actually?
You watch your whore mouth. Hmm.
I mean, that's why we're looking to automate it.
Yeah.
Yeah.
I really hope that one day I can just be like, all right, AI, do all the math for this idea. Oh, the math is done. It works. Cool. Let's go. That way everybody would make all of this shit completely fucking useless. So
Is it not already?
no, the only thing useless here is you.
That's
That
correct.
was mean. That was mean.
I mean, it's not wrong.
It's
I mean,
not
depends
wrong.
on what you're using it for.
A
Yeah, I'm really good at calculus.
he's really bad at finding fucking moments though.
Yeah. I did not deserve to pass statics, but like put me through, so I didn't learn more.
Either way, right?
Solve mechanics.
So we're given. This is problem 2, by the way. Later, man. Does it matter what my name is or isn't?
As long as you have a mask on.
Right? Not as long as I have a mask on. Fucking right.
Like you're
You can call yourself whatever you want. After this review. I don't care.
giving me a weight right now? I usually can do that.
What is this? This is good.
Cappuccino.
Fuck yeah.
I didn't know what to get, so I just grabbed one thing that sounded like
So I know what
common,
the
don't drink
problem is.
coffee.
Why?
Now I asked you and told
I
me
am
it's gonna be the
today,
same,
but,
but it's not.
Why no drink coffee?
like
Coffee
it?
is good.
That is not the same.
You like
as she has.
I like them, but I stay away.
Let's see.
Hi,
Showing
hi.
showing axial constraint effects. Oh,
Yeah, there should be 2 right
this
there.
is one of the.
What's the formula of
need to strategically drink it like tomorrow morning. So they
Oh, yeah.
Okay.
So be tuning for
So we're looking for.
Yep.
Sigma
that'd
Z
be the problem.
1
want
2.
to like get 50 each other just to make something to drink or buy something.
So to do this problem, what equation do we use?
This is where you use all those charts.
This is where we use all the charts. Exactly correct. So
So you can't tell them.
we need to know what the centroid is. We need the centroid. We need IXX and IXY. Or I'm sorry, an IYY. All right. We should notice immediately that we have symmetry through here. So IXY equals 0. Recognize the symmetry, or you will fucking waste a bunch of time doing your stuff. All right. So we have the centroid, we have IXX and IYY. Once we have both of these, we can write sigma Z1 to 6, right? And then we win, and it's over. So we have boom. 1, 2, 3, 4, 5, 6. We have X tilde, we have Y tilde, right? Now, for this part, when we're determining the centroid, it doesn't matter where you pick your centroid or where you pick your origin, as long as you pick it and stick with it, right? For me, I pick my origin at 2 because it makes my life easier, right? So I say my origin, right? Boom 2 is located at 0, 0, so that's cool. Boom 1 is located at 0 and 250. Boom 3 and 4 are both located at y is 0, and this is 250, and this is 250. We notice. Oh,
That one day when
we have boom areas also. We're getting there. We're getting there, right? This is for the centroid determination.
That's actually
Right.
fun.
So then for 3 and 6, we get 250. And for 4 and 5, we get 500.
Is there anyone still watching this stream?
Yeah, we have
27 people.
17 people still watching the stream, which is wild, actually. I really hope this is useful for you guys.
Plug yourself in, bro. Like my Instagram.
Fuck my Instagram. What's on my Instagram? I don't post shit. What are the areas, right? A1 and 2 are 900.
Alright, I'm gonna do this.
900.
I mean, on LinkedIn.
Yeah, if you want to add me on LinkedIn, that's fine.
Like my group me post.
um,
Never like goes a long way.
so we make this chart, right? And this chart tells us where the centroid is. So right, so we end up with 187.5 and 125 for the location of the centroid. Now, here's the other part, where
For this question, I was sorry. He had no idea what I was going to ask you.
we say booms,
How did you know that X?
we have X bar,
X
we have
bar,
Y bar,
Because
we have
it's
sigma
symmetric
Z.
about the x-axis.
Now,
anytime it's
Making
symmetry
this
on that-
second chart here with these 3 columns is
There's
the
symmetry about the
most
axis.
organized way that I've
Okay.
been able to
That
do
makes
this
sense.
yet, and it keeps it all pretty simple. Right. Oh, once we notice symmetry, the sigma Z equation, because we have to use the big one, the big yucky ass one. But since sigma Z is 0, or since we have symmetry and IXY is 0, that simplifies a bunch to the simplified form, which is also on the formula sheet. Take advantage of that.
If we have that shape.
If you have that shape, I mean,
It's like
she's probably going to give us symmetry anyway.
And she might give us something that.
If she doesn't give us symmetry, then fuck it.
it'll take the
But
whole class solve the one question.
well,
If she gives us that old.
Yeah, I know. Like, I'm gonna fucking die if she gets
yes, there is a reason that we use the bar between 1 and 2 as a reference point, because there are no booms on the other side of 1, 2 in this little, what would be the leading edge of the wing. So that's just where we started.
You should draw the
Just
centroidal
talking to
point.
somebody on
You should draw the centroidal point on there, so it makes
centroidal point. It's kind of here-ish.
it'll make more visual sense.
Right. So this is our centroid. Right. Now we say 1, 2, 3, 4, 5, 6. Right. We have our same booms. Now, when I was doing this problem on my own, the first couple times. No, not the first. The first time. I thought about the booms in a numbering system that was different from the one that she gave. So be careful about that. Okay. So she went counterclockwise in her numbering, and she had a 1 and 2 are have the equal, or I'm sorry, boom 1 and 2 have an equal area, and all the other booms have an equal area. I thought about it in a clockwise numbering system, which is how I normally number, which fucked me up real bad, because all of these measurements would be different, right? So now we measure from the point 1, or from the centroid to point 1, right? So we have to go minus 187.5. We have to go up 125. For this, we have to go down 125. We have to go back 187.5. That is how she did it, right? Yeah. So for 3 and 6, for the y values, we're going to have minus 125 and 125. For 4 and 5, we have minus 125 and 125. Right, for the y values. right? Try to keep everything together, right? That way you don't mess up. Now, 3 and 6 will be equidistant from the centroid. And that value, yes, 62.5 and 62.5 and 312.5 and 312.5, right? If you make this chart, you won't fuck up either putting in your x and y values into your sigma equation or putting in your x and y values into your ixx and iyy equations, right? Since we have booms, we have the simplified ixx and iyy equations, which are and that, right? So then we use those, we run it plug and chug. Then we say, all right, well, we've got the ixx, but when I'm looking back at my sigma equation, I need an mx and an my, right? So how do we determine mx and my?
Convert the integrated load into a single,
And then
and then take the moment about the.
perfect, right? So we take this distributed load and we convert it into a single load that's acting here, right? Then it has this moment arm. It's causing a rotation about the x. So mx comes from this load and my comes from this load. The load that's horizontal in the xz plane causes the my rotation, and the one that is in the yz plane causes the x rotation, the mx, right? So determine it by right hand rule, by visual inspection, however you're comfortable with, but do that. And remember, of course, that distributed loads act in their centroid, right? When you concentrate them, they act at whatever the centroid there is. So if she fucks with us and gives us a load that we have to integrate, or a triangular load, or some kind of weird load, we have to go through the centroid of that load, right? So lots of finding centroids. But once we get here, right, once we find mx and my equals whatever,
So are you?
From before, right? This is why we said to make sure that you understood the positive sign or positive assumptions for the moments, right? Because about x,
Good luck.
we have counterclockwise positive, which is normal. But about y, we have clockwise positive, which is the opposite of normal, which makes this moment negative and this moment negative. Right?
Say that again, what are they?
Because sign notation. Moments about x are counterclockwise positive. Moments about y are clockwise positive. Don't ask me why. I don't know. That's just the rules, and you follow the rules, and you get the right answer. I mean, I'm sure they explain it in the book, but really, who wants that explanation? God, there's not enough coffee in the world today. Hi. Hey. What's up, man? Welcome to the show. We're doing a bunch of bullshit. Cool. But from here, we write our sigma z equation. As soon as we have our sigma z equation, we already have all of the x's and y's that we need to evaluate sigma z at already here in this little table that we made. So you write your equation in your calculator, and you say, all right, evaluate it here and here. You say, all right, run that, etc., until you're done. And then you get some numbers. Right? Yes, Anna, you did. Oh, Christ.
Want some Coke?
No. Wait, cane or like cola? One changes my answer. Cola changes the answer to yes, not cocaine. Don't do drugs. Drugs bad. Okay. Why is the front load bearing creating a negative moment? Because that's what the rules are. I don't see how it's clockwise. Because clockwise is positive for moments about y for this stuff.
I didn't pass the test.
Well, looking at it there, how you have it drawn, wouldn't the
These are the positive moments, right? How they're assumed to be positive.
No.
Yeah. So these are positive assumptions, not the moments created by these forces, right? So it's on page 494 of the books.
Mr. Mo. Damn, that music's loud, isn't it?
And there's probably an explanation there for why it is that way,
Mo is
but
short for Muhammad, right?
just remember the rules.
You've known me for
Fine.
2 years and now you're asking that?
How do you not know his name?
You've
No,
known
I
me
know
for
it's
for
Mo.
shame.
You've known me for 2 years and now you ask that,
I
bro?
know that it's Mo, but I just assumed it's for Muhammad.
I mean, yeah.
I mean, it could
You're only
be,
2 years late, but yeah.
right? But you never really kind of like.
My parents don't call me that.
You never introduced yourself as Muhammad. You said Mo.
I mean, force of habit.
Oh man.
Just be called Mo.
Yo, who's
You
this
go by
guy?
Gabriel? No, you don't. You go by Gabe.
I don't
I
know.
still say, hey, I'm Gabriel.
But at least I know your full name. You can say shit.
That was true. He just told me like,
Hmm.
yeah, I'm Gabriel.
Really?
Yeah, he did.
People that know me call me Gabe. But when I introduce myself, I say Gabe.
Thanks.
So can you solve one more? So I'm being retarded. Forgot.
Can we solve MY? Yes, of course I can solve MY.
Do you have a
For
glass
this
though?
problem, this is problem 2 on the review.
Because
Make these
it's
fucking
something that you
tables.
might want.
Make the table for your centroid.
I have a
Make the
laptop.
table for your
Well, doesn't mean
IXX
you have
and
a laptop.
IYY and your Sigma Z.
I'd be a smart ass.
Right? Just fucking do it. Just do it. God, I wish I had the balls to be. Oh, what's the guy? Yeah, to be Shia LaBeouf in the library right now.
I have some
Take out
info.
those little arts majors. Only you do real work.
Bro, I could throw that eraser at those little ones majors and that would clear them out.
Just don't worry about it. Just open the file. And you'll be good.
Vaccines. Just be a real man. Don't get sick.
Yeah. What are vaccines? You can
Mod
you can
X.
fight
Are you
measles, right?
fucking porn, bro?
giving children.
Yo, he's watching porn in the
Right, oh, yeah.
library? Oh my god.
Thank you.
About to go
Yeah,
to the
man.
fourth floor and make some porn.
So
You said you're gonna go to the first floor and make some porn?
Fourth floor.
Oh. Yeah,
So
because nobody's up there.
5,000.
Right?
Why not right here?
times 2,500.
Dude, they already had the lighting up. You're good. Just put some blinds on the.
We need the black leather couch back there too.
Black leather couch.
Future Catholic.
All you need is a couch and a camera.
That shit.
Oh, you dumbass.
There you go. There's your moments about why, guy.
Oh
So
shit!
just
Wait,
think
give
about
me
it and
I did
Do
the
you like
wrong one.
write down the numbers?
You would have been like, what the
1
fuck?
times
You would've been like,
5,000
this is
Oh, no.
times
I got you.
2,500 equals
Let me.
stuff.
Drinking
Wait.
with coffee,
No.
hands shaking.
5,000?
No, let's not get Seetha in the chat.
Which
Bad idea.
which one's this?
This is the determining of my from
Oh, for this one.
2. Yeah, that we just.
Okay.
Yeah, totally
Oh,
goofed. I totally goofed it. bro.
I still feel like you're the only person who actually understands everything in this class. Maybe this kid, but
Shouldn't it be 5,000, not 500?
my hand's shaking.
You're fucking blitzed right now.
Too much coffee.
There we go.
You're a fucking
Just
asshole.
open it up.
Yes, I might have forgotten a
Oh my
zero.
I'm thinking.
Yeah, I'm glad that you're thinking.
Off by power of 10. Grades off by power of 10.
And your grade's going to be off by more than just 1 power of 10.
Yeah, I
Which
know.
one?
You'll see.
I have so many shit.
Just look for it.
Oh,
Did you put it in a folder or did you put it?
Man, there's like all
So-
of engineering are not that much.
Oh yeah. I drink 3 of these a day.
You
what do we have? Can you put up
That's how I
question 1 for me?
not that bad. It has what? Coffee probably has as much caffeine as that.
This is the first time I've had coffee. in
Yeah,
a
but
month.
coffee doesn't
But
have
some people
taurine
drink
or
5,
ginseng
6
or
cups a
all that
day.
fucking
Second time was really
shit.
good morning.
No,
Um,
I didn't drink 3. This is my second one. I just usually have one in the morning and then one at night when I'm trying to stay up.
Drink a monster before bed because it relaxes me.
Nah, 3 would be a little bit.
What the fuck kind of crackhead shit is that?
No, I can't sleep when I drink caffeine. I just stay up.
That's normal.
But my girl, like, she drinks coffee right before bed, and then I'm like, what the
I thought
hell?
you
is
were
wrong?
judging
Is
me from the
everybody
music.
Yes, everybody's judging you for your music because it's shit music.
asleep? Yeah, and they're not even AirPods, so you leave me.
It's not even
food
like
points.
good.
They're just freaking AirPods. They're
AirPods are
freaking-
not good choice.
Yeah, it's like what millennium is this?
There's some good Dean Martin tunes.
Well, I'm prepping myself for ET this weekend. By the way, I can't find it.
What are you talking
I
about?
put-
You
I-
can't find it.
It says the last
No.
file was added
Um,
is back in October 24th.
Huh?
Fucking retarded. You're
Um,
fucking retarded. That's why.
so for the first
Oh, I know
page
that one already.
of the
Oh, you
review,
do?
Yeah.
Oh, fuck you then.
we're given
I think it's
this, and it asks us
You have
to
that?
find
Where the hell did you get it?
the general shear, right? Q general
For him?
for this,
So
right?
everybody has
Give it
it.
some
Okay, never mind.
VY,
So why don't we just do this?
which is, as always,
beats me.
We should just like master this real quick.
I hope this isn't the exam though, because like these next questions are pretty brutal.
I forgot.
Did you finish that last problem you were going for
Yeah,
2
but-
hours? No?
I did.
We
I did.
practiced it
Right.
like 10 times.
We only
I know how to
have
do it. I don't
this
know why,
one
like, I was
unknown,
trying to do it, it
right?
just kept
This is
taking
the
me too
only
long.
thing that we need to
I
know.
don't know what to say.
And in order to get that, we need to determine where the centroid is,
You need some Adderall.
and then from that, determine what the IXX value is. Something to remember, since we don't have booms, IXX takes its expanded form.
What else you have in there?
Right?
I can do whatever you want, to be honest.
So this is for problem 1, or yeah, problem 1 on the review for part I.
That's all you want.
But that's the only unknown. So just be careful about calculating your centroid and your IXX. Remember that you need the bigger formula for IXX because we don't have booms. If we don't have booms, we use the big formula. If we do have booms, we use the small formula. It's the whole thing.
What's up after the interval?
I don't know.
Some thickness times the Y. Oh, that's DS, not DY. Where that is the
So
length
it's
that it acts through. Yeah, so perimeter. Oh,
Do you have bounds of integration? Or
no, because for this particular problem, they only ask us for the general form, so we don't evaluate at all. We get
I just wonder
we,
what that
we
was.
only
about the
solve
whole
for this
interval.
first part, and we don't have to solve for this part.
Yeah,
Right, and then you can locate the shear center of this by visual inspection. It's wherever everything goes to 0. Right, so it's 0.2 because if you take the moments of everything, well, Vy acts through it, 1-2 acts through it, 2-3 acts through it, 4-2 acts through it. Everything goes to 0. Bada bing, done. If the shear flow in the section is idealized, then the shear flow will be constant. If it's not idealized, then it won't be constant, right? If we, for some reason, had booms, right? Then the direct stress would act through the booms, and the shear stress would act through the skin only, right? You wouldn't have direct stress in the skin. You wouldn't have shear stress in the booms. Direct stress in the booms, shear stress in the skin. because she will ask that question on the exam. It was on the review. It was on the old exams. It was on the old reviews.
What question? Can you repeat that?
Was if you have an idealized section, where does the direct stress and the shear stress act? Where do the direct stresses and shear stresses act? And the direct stresses act through the booms, and the shear stresses act through the skin. No matter how she phrases it, you got to know that, because she can phrase it however she wants. It's her exam. Is that the Old Spice thing?
Yeah, it is.
You okay there?
Okay. Oh. And then
I'm looking at the screen, dude.
one other small part, right? When we have booms, we have to cut. And we have to make sure that all of the shear flow sections have been opened, right? So we can do it like this, and that's good. Or we can do it like this. And that's also good. Or we can do it like this. And that's also good. So as long as all of the sections or all of the loops where you have shear flow are open loops, you're good. If one of the loops is closed, right? So if, for example, we did this, we said this, then this would be no good. No good anymore, because this is closed, right? It's got to be open. Huh? Yes, just like in EE. Yeah. It's a bunch like EE, because current flow and shear flow are internal flows, so they basically act exactly the same.
Dude, you're bridging so many gaps in all my classes.
It's because they all go together.
Math,
All of
math.
these engineering classes go together. Everything is hand in hand. I think that covers the entire review, actually. Yeah, we did 1, 2. So we just went over all the sub questions for 1. We did 3 and 4 to start with, and then we just did 1 and 2.
Oh, hell, Peter Parker. I hope you get on Snap.
Anything else that anybody wants
Sit next to you.
to sit next to me for the exam? I want to sit next to me for the
You
exam.
want to go over this
What is this?
old guy?
No, not really, but yeah. Okay.
They could be really similar or the same.
Well, it's going to be really similar to our exam review, right? She said to study the exam review because it's going to be similar to the exam review. And
Boosie told me that too.
yeah, but Boosie's a liar. Seetha isn't, as far as I can tell. How is that racist? Seetha tells you something, and then it actually is that. Whereas Boosie just makes up nonsense.
She told me that before.
Yes, but this does look similar to that as well.
All right. I'm gonna pay you a good $1. Yeah, man.
Someone's giving me $1.
What, a whole $1? I wish. Get paid for my streams.
I paid you in capital.
Oh, you're live streaming?
Yeah. Yeah, so if anybody else that's still here wants anything, I'll do it for you, but give you a couple minutes to figure it out. Otherwise, I'm going to Hey. Otherwise, I'm gonna shut down the stream.
We also need to lock the door, and before I can leave, they need to check. They're gonna check that. Yeah, they need to check.
Thanks.
I didn't even know you were doing that the whole time.
Yeah, I streamed the whole thing. All right, guys. I think that's pretty much all. All right, cool, guys.
That's more of I learned
That's
nothing.
what the rest
I
of us.
probably got like a 60. So.
I'm feeling like
Average watching time. Holy shit.
75 pounds.
Yeah, same thing.